Hello everyone, I hope you are doing well. In the previous video, we learned about function. We've learned all the basic concept and what we can do with function, how we can define them using scope and all that. It was a long video, but I hope you understood all the concept that I wanted to convey. If you're facing any difficulty, please comment out and I'll try to solve each and one of them. In today's video, we'll learn about more of the built-in function that Python provides. We know we can create our own function using def keyword, but there are many functions that Python provide out of the box. We have used many of them. Today we'll be looking all of them in alphabetical order, that is from A to Z. There are almost 50 of them and we'll look one by one towards those. So let's get started. First we'll be looking at one called all. So what all does is it will take an iterable, that is like a list or sets, and it will see like if all of them are true or not. So you know in Python true means one or any string, non-empty string. So let's see how all works. So how all works is, suppose we say list is 1. Let's consider a list. It can be any sequence, okay, like you can say tuple, you can take sets. So let's take a list 1 2 3 4 5. Okay, now how you can do all? You can just write all and pass the list like this. Now if you run this, see it returns true. Why does it return true? Because if you see all the element of this list, right, are number which are non-zero number. So if it's non-zero, that means all are true. But suddenly if you put here 1 0, right, and run this, see it gives false. Why? Because we have one number that is 0, and you know in Python 0 also means false. So it checks if all of them are true. If any one of them are false, then it will return false. Suppose it's not 0 but it's an empty string. You know empty string is also false. So if you run this now, see it still return false. So that is how you can say you can use this all function to check if all of the items in a list or in a sequence are true or not. So that is how we can use all. The second one is any. It's like all, but here is like if any one of this list is true. So how you can use? Let's check one more time. Let's take a list called list1 equals to 1 2 3 4 5. So in the previous, this was the same example and we did all. Now let's do any, any, and do list1. Okay, now if you run this, see it says true. So that means, but you may say that there is no 0, but even if you put 0 here, right, still it will give you true. See it still gives you true. Why? Because we are not checking all, we are checking any. If any of them are true, then this function will give you true. We know that there are 5 truths, so if even one of them are true, then also it will return true. That is how you can use this any function. The third one is bin. We have used this if you remember when we were working with bitwise operator, right, then we use this bin to get the binary of a number. Binary of a number is a 1-0 representation of a number that computer understand. So suppose we wanted for 4, okay, so what we can do is print. We are printing it, you can just put it in a variable also. You can add bin and put the integer in it. Now if you run this, you'll get the binary representation of it. Let me comment this out and run this once again. See, you get the binary representation. You'll be getting 0b, that is just saying that this is binary representation, and the last numbers are the binary of it, that is 100400. If you wanted to remove it, you can use slicing like this, and you can say remove 2 of it. And now if you run this, you'll be getting only the binary number. You won't be getting the 0b. But keeping the 0b is good because you know it's a binary form. So that is how bin binary works. Boolean is like just converting anything to boolean true and false. Like I said, like 0 means false, right? So if you wanted to check that, what you can do, you can write print or put it in a variable, write bool and put 0 to see if it's false or no. Now if you run this, you can see it prints false. Why? Because we know in Python 0 means false. Similarly, there are some more false condition, like an empty array is also false. So what you can check like this, you can put empty array here, save this, and if you run, see both of them are false. And even empty string is also false, you know. So what you can do is you can do print bool empty string and run this. See, this is also false. But if you put any number other than this, right, it will print true. Suppose if you do print of bol and print 1, this will be true because we know any number other than 0 is true. If you see the last one, this is true. So that is how you can use the Boolean function. Now let's come to one more, is called complex. So complex, mostly you'll be getting this in when you're doing mathematics class or something. So complex number is it's a combination of real and imaginary part. So how do you represent this? You represent this by a plus ib. If you have taken math class, so this should be familiar to you. So this is how complex number is represented. So in Python, how you can do is you can just write print complex and put the number in. Whatever number you put, this is the real part. Okay, now if you run this, see, you'll be getting 12 plus 0j. So that is how it is. Here a is the real part, so 12 is the real part. Here, since we did not pass an imaginary, that's why we got 0, and here b is the 0. Okay, b is the 0 part, and here I means it's represented by j. So if you wanted to print the imaginary part also, what you can do? You can do print complex. You can write the real part, and you can put imag and put the imaginary part. Suppose it's to 5. So now you should see 12 plus 5j. See, now it's a 12 plus 5j. Here 5 is the b, 12 is the a, and j is just saying the I, that's saying that this is part of imaginary. So that is how you can use complex number in Python. And then come the DICT. So you can put a dictionary like this, right? You can make one dictionary like DICT1, and you can do like this. So this is an empty dictionary. So there is also one more form how you can create is using the DICT keyword. So what you can do is you can do DICT2 equals to DICT. This is also an empty dictionary. Now if you run this, print DICT2, it will still give you the empty dictionary. See, it's an empty dictionary. So to create an empty dictionary, you can use DICT. And if you wanted to directly print the dictionary, you can also do the same way. You can write DICT and put the dictionary itself here. So you can write A1. So we have already learned how dictionary works. If you wanted to learn, you can watch the dictionary videos and you should get familiar. This video is all about just getting to know what are some of the built-in function that Python provides. Okay. Now if you run this, you don't get anything because we didn't print it. Now if you print out DICT3 and run this, see, you'll be getting the dictionary. So that is how you can use the DICT function. Okay. To learn more about dictionary, please watch our dictionary video. Then come dir. So we know that every dictionary list, they provide some other functionality, like dictionary provides something called get, and on list we get something called append, right? So if you wanted to know what they provide, what you can do is you can just write, suppose this is a list, okay, list1 and 1 2 3. So if you haven't watched our list video, then you don't know what are the properties we can do using list. So to know that, what you can do is you can do print dir and put the variable inside it, list1. Now if you run this, see, these are all the properties that you can do using list. So see, we have learned about append, clear, copy, count, extend, index when we are doing our list. So to know what are the operation you can do in list, you will be all getting in this form. So that is how you can use dir. So if you don't want to use directly like this, what you can do, you can even write like previously we learned DICT, right? So you can just put print dir DICT, how you create an empty list. Now if you run this, you'll understand that you're looking for dictionary, and you'll print all the things we can do using dictionary. We have learned about clear, copy, from keys, get, item, key, pop, right? So that is how you can get all the functionality that a type can provide for you using this dir function. Okay. Now come div mod. So we have learned when in the arithmetic, right, we have learned how modulus work, that is how percentage symbol works and gives you a reminder how division work. So if you want to do both of them together, you can use div mod. So what you can do is, let's print out div mod. Suppose we want to divide 10 by 5. Okay, so you write 10 by comma 5. So here if 10 is divided, let's run this, then I'll explain you with the solution. So you'll be getting a tuple. So you know what tuple is. It's like putting in parentheses all the different elements in it. So if you don't know tuple, please watch our tuple videos. So what this does is, first it will divide this 10 by 5. So 10 divided by 5 is what? 2. So it will give you this 2. Then what it will do? It will also do 10% 5. So 10% 5 is 0, because if you divide 10 with 5, the remainder will get is 0. So it will put both of them in a tuple and give you like this in the form 2, 0. Okay, that is how div mod works. Now let's come to enumerate. We have learned about enumerate when we are learning about list. So what enumerate does is it will give you the value of a list and also the index when you are in a for loop or you wanted to loop over them. So how you can use them is, suppose we have a list, list1 equals to hello, hi. Okay, now if you run this in a list for, let's run this list for word in list, for word in list 1. So you can do print word. Okay, now if you run this, so you'll be getting only the element of it. But what if you wanted to get the index of it? So we know there is one more way to get the index, like using the index property. But what if you wanted to get directly using for loop? What you can do is copy this, and before the word put the index or whatever the keyword you want, and wrap this list one using function enumerate, and put here. Now if you run this, you can put the index. Now if you run this, see, we'll be getting the index also of this word. So that is how you can use enumerate. We have learned about enumerate when we are doing our list. Please watch that video to get more in depth of enumerate. That is how enumerate works. Now let's come to eval. So eval is if you wanted to do an operation. Suppose there you get a string. Okay, you get a string like this: 2 plus 3 divided by 5 plus 7 multiplied by 8, something like this. Mostly in math class or something, when they will give you and they'll ask you to solve this. What you can do in Python, since you don't need to take out what is plus and how to do this, simply what you can use the eval function. So you can do eval and put the string one inside it and just run this, and this should give you the solution. See, 58.4. So if you wanted to take a string and do the evaluation like mathematical expression or something, you can use this eval function and put the string inside it, and it will just solve your function for you directly. So this will be more useful when in mathematics class or when you get a long string of calculation and you wanted to solve in one line. So you can use this eval. But if you wanted to, suppose they don't give you this, but they give you something like function in a string. Okay, so suppose they give you a function like this. So let's say string 2. So to do multi-line string, right, you can use 3 quote like this, and you can put here. Suppose we have a function. You know how function works. So let's create a function called run, and let's say print this is run. Okay. Now this is a string. This is not a. It looks like a function, but this function is inside a string. So if you wanted to run something in a string, okay, that is a function. Definition is like a function. If you want to run it, you can use this exec. It's an upgraded version of eval. Okay, eval is mostly used for expression, but if you wanted to run a script that is in string, right, you can use this exec. So now if you run this, if you run exec and put this string in it, str2. Now if you run this, you'll be getting something like this. See, you got nothing, because when we are learning function, we say that function by itself does not run. If you wanted to run a function, you should call that function. Now let's call this function here inside the string itself. Okay, now if you run this, see, you'll be getting this is run. So if you wanted to execute a Python script that is inside string, then you can use this exec. Or if you wanted to just do an expression, solve an expression, you can use this eval. Okay, so this is a simple example. Try putting any script inside a string and doing it, and you should get the same answer. Now let's come to something called filter. So filter by name itself says like we want to filter something. So let's create one more list called list2 equals to 1 2 3 4 5 6 7 8. Okay, so this is a list, and now if you wanted to filter only the even number, so what you can do is let's print, and you can call this filter function, filter, filter. Okay, this filter, the first parameter needs to be a function. Okay, so how this works is filter, then first parameter need to be a function, second need to be the iter. Iter means which can be looped over. Okay, so let's define a function. So let's put a function called isEven, and it will take a number and will give true and false in return. Okay, so return number % by 2 equals to 0. So if it's even, it will be equal to 0, right, when you do percentage module, since any number which is divisible by 2 and gives a remainder of 0 is an even. So this is an even. So you can call here is even, and you can put the iter called list2 here. Now if you see carefully, we did not pass the parenthesis here. Why? Because we are not calling the function. For the filter, we are just giving a reference to which function should be called. Filter by itself will call this function, put one number in this function and calculate this by itself. So if you run this now, see, you'll be getting this in a filter form. Now if you wanted to get this in the list form, what you can do is cast this filter with list. Okay, cast this filter with list. Now you should be getting in the list form. See, you'll be getting only the even number. So how this works is, filter, you put a function. Okay, you put the reference to a function, so you don't put parenthesis. We are not calling the function, we are just giving reference to filter what the function needs to be called. And if you don't pass here num, right, then this won't work. If you run this, see, it throws an error because by default filter will pass one argument to this function. So you need to make one argument mandatory for this to work. So now if you run this, you'll be getting this even number. So this is how filter works. I hope you got that. If you are facing difficulty, please comment out. Okay, I'll try to solve your queries. Now let's come to the second one. Is called float. Float is just converting a number into decimal point number. Suppose we have an x equals to 10. Now if you print this, print x, this is 10, right? So it's a type of string. Now if you want to convert this to float, what you can do is you can just write float, put this x here, and now if you run this, see, it comes in the decimal form 10.0. So that is why it's a simple function to convert string to float. Okay, so that is how this works. Then come format. We have already learned how fstring work. Okay, so similarly like fstring, there is also one thing called format for formatting our print statement in a string. How this works is, suppose let's take a name here, name equal let's code together. Let's code together. Okay, so suppose this is a name, and what did I write here? Name. Now if you want to print this, what you can do is you can say subscribe to, put like this. Okay, put curly braces like this, close the string, put dot format and put the name here. So what this will do is, it will search for this curly braces, and one by one it will start putting the name in this tuple. So if there are more variable, you can put, suppose now let's say when equals to today. Suppose this is the second variable. Okay, and we can put like this. Now you can put a comma here and put when. Now if you run this, see, it says subscribe to let's code together today. So that is how you can use format. So format also can be used using name, how you use in fstring, right? You can put your name, put here when, and just here you should put the same way. You need to put name equals to name, when equals to when. Now if you run this, this will still work. So there are two ways to do that. One is this one, and the other is using just the curly braces without using the variable name inside the curly braces. You just put the variable name in tuple after the format keyword. Okay, so that is how this format works. It's used for formatting string, but I'll say most preferably use the f string that we have already learned, because that is more useful and that looks more cleaner than this format. Okay, but yeah, it's up to preference of what you're doing for your project. Now let's come to frozen set. So we've already learned about set. So we know set is mutable, that is, it cannot be used when using key in a dictionary because we cannot use mutable type, and mutable type means which can be changed. We've already learned about this. So frozen set, by the name it goes, it froze the set, means you cannot edit set after creating it. So how you can do this? Using just a keyword called frozen set. So you can read FROZEN frozen set and put the set inside it, 1 2 3, and now if you print this fset and run this, yeah, it behaves like a set, but here now you cannot add anything. Fset, in previous one when we are doing a set, right, we used to add number like this at 12 and it will add number. Put fset dot add add. This is how we used to add number in set. But now if you run this, see, it will say frozen set object has not attribute add. Why? Because frozen set means once it's created, it cannot be changed. This behaves like how tuple works for list, right? So once it's created, it cannot be updated. That is, it's immutable. So that is how you can use frozen set. And now you can use this variable as a key in dictionary. Okay, but you cannot use set as in dictionary because set are mutable. Frozen set are immutable. Now let's come to the next, that is get attribute. So get attribute is to get something from any sequence like dictionary, list and all that. It's like what are the attribute are like what are the functionality that the things provide and you want to add them. Get, add, set or hash, you want to check them, then you can use this. Suppose we are using a list. Okay, so we have one list called list1 equals to 1 2 3, and what are the attribute of it? We have learned that when you print dir of list1, you'll get all the attribute of it. So now if you run this, see, you'll be getting all this. I can use append. So using this get attribute, what you can do, you can use this append also. So what you can do is you can do something like this. You can see attr get attribute, where on list1, what is the thing you want to do? We want to append, and you want to append what? You want to append 4. Now if you run this, print list1 and run this, see, you'll be getting 1 2 3 4. So this is just a way to get an attribute. These are mostly used in classes and not used here because this does not make it look clearer, right? So when using classes, then we'll be using get attribute, set attribute. But for now, you know that this can work with all the attributes that this data type provide for us. So you can skip this get attribute, set attribute for now. When we'll be doing classes, right, then we'll come to this back because it will make more sense there. Here it does not. It just spoils the way Python looks like. It does not look clean. But it's better to write list1.append and put 4 there itself. So that is how get attribute works. But for now, I'll say just skip this part because we'll be learning this when we learn our classes, right? Then we'll learn this in details. Now come globals. Globals means it will say you what are all the properties that you're using in this script. Suppose let's say let x equals to 10. Okay, then we have one function called def run, which will return run. Okay, then we have y equals to 5. Now here, what are the things that are in part of this script? X is part of script, run is part of script, y is part. If you want to know what are all the things that are part of it, what you can do is you can write globals and put in a variable. Now if you print this g, right, you'll be getting all the properties that are used in this script. See, this for now you don't have to think of all this underscore. We'll be learning about this slowly by slowly. But see, we know the file, where the file is stored. We know where it is it cached or no. Then we know the value of x is 10. We have a run, that is a function, y is 5, and g is the globals of it. So if you wanted to know like what are the things that are being used in this script, right, you can put a variable and assign globals to it. Then you can know everything that is a part of that script. Okay, that is why globals are used. This is just for reading purpose, like what you wanted to see, like what are the things that are getting used in this script. It's not a must know feature, but just in your back of your head you should know that there are some properties called globals where you can use to know what are all the attributes, functions that are part of this script. Now come has attribute. Has attribute also works like get attribute. So I'll say we'll discuss more on class. When we're doing a class, right, then we'll do this has attribute, get attribute. For now you can just skip this. Okay, this is same like how get attribute, it will just check if a variable has that attribute or not. Okay, let's come to hash. So we know what are hashable and not hashable. Hashable are which can be represented in numerical form. So any data type that can be represented in a numerical form or any data structure, that are called hashable. Hashable are only the things that can be used as key in dictionary. So how do you do that? Suppose let's take a list. Okay, so you know lists are mutable and mutable are not hashed. So now if you do print of hash of list, let's make it list1 because list is a keyword, and run this, see, it will throw an error. Why? Because it's unhashable. But if you take a frozen set that we learned just before it, I said that set is not set is not hashable, set is mutable, but frozen set is immutable. So let's take set, frozen set, okay, f set, okay, so frozen set and put 1 2 3. Set are not hashable, right? But frozen set are hashable. How you can verify this? You can put hash and put f set here. Now if you run this should return you a numerical form of it. See, you get a numerical form. If you get a numerical one, that means it can be hashed and that can be used as key in dictionary. So that is what hash is. It will just give you a numerical representation of this data type. Now let's see the next one, that is help. So suppose if you wanted to help in any keyword in a Python, okay, suppose you wanted to know what does if clause do, though we have already learned what if clause do, but if you wanted to learn what if clause, you can just do help HELP and put the keyword here. Now if you run this, see, it will give you a complete details of what help is. If you see the if statement is used for conditional execution. It select exactly one suite by evaluating the expression 1, like this. So if you want to know about any keyword or anything in Python and you don't have online support, what you can do, just use help and put the keyword inside it and it will give you all the details in it. Okay, and you can go forward. So that is the use of help. This is helpful when you wanted to just wanted to see like what it can do and how to use it. So you can use this help. Now let's come to the next one, that is hex. Hex is the hexadecimal number. A number can be represented in binary form, hexadecimal, octal. So to represent in a hex, what you can use this hex function. So if you wanted to represent hex of a number like 200, then you can just run this print hex of this number and it will print 0x. 0x means the hex, it's part of hex. Like for binary it prints 0b, for hex is 0x, and C8 is the representation of 200. So when you wanted hexadecimal number for any integer type, you can use this hex. Okay, these are useful who wants to deal with hexadecimal number. So but it's not always necessary, but sometimes it's required. Then comes the ID. We have talked about ID when we are learning list, to know that two lists are not referencing the same memory location. So that is how we use ID. So suppose if you wanted to know what is the ID of a list, suppose this is a list, okay, 1 2 3, and this is a number x equals to 100. So if you want to know what the memory reference of it, you can just print of ID of st1 and print of ID of x. So it will give you a memory location or a number representation to show where it is located. But if you do a list 2, okay, list 2 that, and copy this list 1 by using assignment, here you can see both of them will have the same memory location. That means changing one will change both of them. If you see the 2 of the top right, both of them present same. This is one caveat on using list. I've talked about this and I've given the solution how to solve this. If you haven't watched the list episode, and you'll know this very clearly. So that is what ID is. The next one is input. We have already learned about input. Input is how to get a user's interaction or how to get results from the user so that we can use it. So it's a simple keyword called input, and you can put a command, you can put a prompt here. So you can say enter your name or something like this, and you can put this inside a variable. So whatever the user enter, so it can be part of the variable. Now if you print this, now let's run this. See, you'll see it is waiting for me to enter something. So we can put this let's, and you can see it get printed. So that is how input is. We have talked about input in depth when we learned about input. Please watch that video. Then comes int. Int is same like how we have learned about float, right? It's just a representation how you can represent anything in int. So what you can do is you can write print int of 10.5, and if you run this, so it will give you 10. It will just remove the decimal part. Int can also work if it's string but it's representing a number. So if you say 1 2 3 and run this, so it will try and see if it's capable, then it will just convert into number. So that is how you can use int. Then come is instance. Instance is to check if it's an instance of something. Like everything in Python is in class, right? So if you want to check if it's an instance of something, then you can do it. Suppose x is 10. Now if you do print type of x and run this, see it's a class of int. Now if you want to check instance, what you can do is you can write print is instance x, and you can put the it's a int, right? Now if you run this, see it will print true because x is instance of int. Similarly, you can do for list, dictionary and all that. You can just write is instance, put the variable name and put the class do you think it's of, and if it's print true, then you can do whatever you wanted to do. Okay, that is what is instance is. Then come iter. Iter is like it's a sequence where you can loop over and things, but iter gives you a functionality called next. You know what iter does is, iter will give you an object, so it won't go through everything, but it will give access to the next one, so that you can access the next, and once it's completed, you cannot come back. Okay, so how this works is, suppose it is in iter 1, but again you can use the iter keyword and pass a sequence. Let's pass a list 1 2 3, and now if you print this iter and run this, so it will give a representation of list iter. So how to print? To print, you can use the next function. If you print the next function, it will give 1. Similarly, you can keep on going 1 2 3. Okay, so it will print 1 2 3. Now if you run one more time, it will throw an error because there is no more after this. Okay, if you see, it will throw a stop iteration. This is how a list works when you use iter. So it will go to the end one. If it reaches the stop iteration, right, then it will stop the iteration. It won't go forward. So that is what iter is. It's just a sequence where you will get access to the next keyword, so that you can run one by one at a time. You don't have to run the total list, or you don't have to create the total list at an instant. You just have a reference to the first, that will also have reference to the second one, and you can go on forward. Now you cannot come back. Okay, that is what iter is. Now come to len. We have already learned about length. Length is to get just the length of a list or a tuple. This is same as this. So now if you run this and put the length of it, print len of iter 1. So this is different from list, as I said, right? Let's run this and see what it prints. It has no object. Why? Because it's still a iter, right? It's not a list of its own. So this cannot be done in iter. But if you do a list, right, you can put the iter 1 and put inside a list 1 2 3 and run this. See, then it will give you a length. Length is just saying how many elements are part of this sequence. But in iter, it's just give you a reference, right? It's not an sequence, means where a representation sequence where you can count how many things are there. You need to go one by one to know how many are there in the end. So that is how len can be used in using some sequence like list, tuple, sets and all that. Okay, that is how you can use the len function to get the length of that sequence. Now come list. List is like, we know to create a empty list, right? You can just write like this, list 1 equals to this one, and this will still give you an empty list. Let's run this. Still give you an empty list, but there is also one more way. Then you can use the list function. So if you use list2 equals to list and print list2, this will still give you the list. See, so that is how you can use. You can put the list also inside this parenthesis using this square braces. It's the same thing how list work. So yeah, this is just a function to represent an empty list, and you can put the list inside it to make it a list. Then come locals. We have learned about globals, right? Globals does not take whatever the inside the function is. So to know what is inside the function, you can use the local. So how this works? It works same like how global works. So you can write re1. Let's create two variable, x equals to 10, y equals to 5, and you can put locals, l equals to locals, and you can just print a l. It will give you access to all the local variable, but it won't give you access to this. Okay, now if you a equals to 10, and now if you run this, it won't have access to the a part. So it will give access to x and y, but it cannot give a because it is just using a local scope. So inside a function, the local scope is whatever is inside the function. That is how you can use local. Same like global, it's not mainly used. It's just to use for read-only purpose, where you wanted to know what are the things that are inside a script. That is what local is. Now let's come to map. We have learned about filter, right? How we can filter a thing. But what if you don't want to filter, but you want to do some computation in that list? Suppose you want to get the square of all the numbers in a list. Okay, so let's create one list called list 1. Put this 1, 2, 3, 4. Now you want to get a square of all the number and put it in a list. How you can do this? You can do this. Put a list 2. Here's the map function. Here you need to put a function. Okay, so let's do square, and you put the list 1 here. Now we need to define this function how we did for filter, right? So we need to define this function. So what you can do is you can define square. Similarly, it will take a number of filter takes. And now we don't return true and false, but you can return anything. So we'll say num into num, because square of a number is multiplying it by itself. Now if you run this, it won't still print you the list. Okay, let's do list 2. Now if you run this, see, it gives you map an object. It does not give you a list. To convert it into list, you can just wrap it inside a list. Just cast it with the list. It will form a list and it will give you, see, you get 14916, because 14916 is the square of all this number. So map and filter both look similar, but one is the filter is just filters out some of the element from this list. Map is to, if you want to do some computation inside the list itself. So this is how you can use map. Here also we don't use parentheses, because we are not calling the function, we are just giving reference to which function should be called. So that is how map works. Now the second one is max. Max is how, suppose you want to get the max element in a list, right? Then it's simple, just put a list 1 equals to 100, 500. Now we know the maximum is 500. To get it, just use the max function. You can use max and list 1. It will just return you the maximum of the sequence, so 5. Similarly for min, you can do minimum of this one, min, it will just give you the minimum of it, that is 1. So you can see here. So this is a max and min function. This is a simple function that are used. Next one is next. We have already learned next in iter, so you can just look at iter and look at iter above. In the iter we saw that if you want to get the next element of an iter tool, so you can use this next function to get the next number of the sequence when using iteration. Then come OCT. OCT means octal. Octal is the same, is like how hexadecimal works, right? This is just given an octal representation of a number. Suppose x is a number called 100. Now if you want to print the oct of it, you can run oct of x. If you run this, see, it will let me comment out this one. Let's run this once again. See, first the 0 and O you need to remove it, just because you know for the octal it prints O. 144 is the number that 100 represent in octadecimal number. Okay, so that is how OCT works. Then comes ORD. ORD means, you know, every character like ABCD is represented in the form of number. The ASCII code is represented in the form of number. To know what it is, you can use the ORD function. Suppose you wanted to know what A means in number. If you in number, right, in 1, 2, 3, 4, what does A represent? So what you can do is you can press ORD, put A and run this. Means small a represents 97. Similarly B will be 98 and 99 and so on. And for capital A, if you want to know, what you can do is you can just put capital A and it will print you something like 65 or something. See, it prints you 65. So capital A is smaller than small a when if you do a logical function, like if you do print A is less than A, it should give you true. Why? Because we know A means 65 and small a means 97. So if you run this, say it gives you true. So that is how any computation or any logical operation or any relational works, because they all are represented in the form of number, and these numbers are ultimately represented in the form of binary form. That is how we can get all this arithmetic way of doing things. Okay, that is how ORD works. Now let's come to the next one is POW, power. Power is like we know to get a power, what we used to do is when we learned about operation, right, we used to do 2 and put 2 star and 3. So that will print you 8, right, because 2 power 3 is 8. But in Python there is one function called POW. What you can do is you can do POW, put 2 and the power you can put in 3. Now if you run this, both of them should print you 8. So you can use this POW if you want to avoid using double star. POW even looks better than using 2 stars because it makes clear that this is a power 2 to the power of 3. That is how POW becomes useful. Now I don't think I need to talk more about print. We have used throughout. Print is just a function. Though we have talked about print in detail in the starting videos, please see that. Okay. Print is, this is a print function. So now you can see that we have been using function from the first class itself. Though we did not know about function, print itself is a function. What it does is whatever you write inside it, will take everything and just put it in the terminal. So if you run this should not be a surprise, and you get it. This is a print function. Okay. So you saw like how function can be being used everywhere, but we just don't know that this is a function, but we are using it throughout. Then come range. Range is a sequence. Okay. So we have learned in range when we are learning about list, we learned about range. So range is a sequence that we can work with. So let's say RNG range of 10. So now if you print this RNG, what do you think will get printed? If you run this, see, it prints that this is range. So range by default is not like list or anything, right? So when we run for loop, right, this range is converted into iteration, then it's written all the number itself. By default, range is just a range function. So how range function works is, we've learned all this. It take the start and step. So this is how it works, and you can use this in for loops. It's mostly used in for loops. So how you can do is, you can do something like this. You can for I in RNG and print I. If you run this, you should see all the number up to 9. Say it's 0 up to 9. So how this works is, if you don't pass start and end position, whatever you pass, this will be the end, non-inclusive end. So 10 will not be included. Any number from 0 to 9 will get printed. You can use the step function. If you want to learn more about this, you can watch the list, because it's better to learn with list. The range function becomes more clear when you learn with list. And on the for loop also we have talked about it. So what's the for loop video and the list video, you'll get more clear about how range works. Then come our next function is reversed. So reverse is whatever the order is, just reverse. Suppose we have a list called list3 equals to 1, 2, 3. What is the reverse of it? The reverse will be something like this, right? It will be 3, 2, 1. But how do you do that? To do that, it's simple. Just call the reverse function. You can do print reversed of list3 and run this. It prints the list reverse iterator. Why? Because we did not convert it into list. So to convert in list, just put the list wrapper inside it and run this once again. So you should be getting 3, 2, 1. So this function does not return the list directly. So to convert it, just use the list function. It will convert this into a list, and you will be getting the reverse of this. Okay. Then come the round. Round is like if you want to round something up to the nearest greatest number. Suppose if it's 1.2, okay. So suppose round of 1.2. So what is the nearest number to 1.2? It's 1, right? So what it will print? It will print 1 for you. But if you do something like 1.7, what is the nearest number? It's not 1, but it's 2. So similarly, it will go to 2. So just rounding off a number. So you can use this. This will become more useful when you're using some mathematical terms and you wanted to go to the nearest integer, right? Then this round function will become useful. Then comes set. We already know about set. It's a, we use this using curly braces. This is an empty set, but you can define set also using the set function. So both of them will give an empty set for you. Set 1. If you copy paste this and run set 2, both of them should give you an empty set. And we know how set works. We have watched this in the set tutorial. So you can see set videos to know how we can add, remove, and how mutability works with set. So that was about set function. Then comes set attribute. This also we'll talk more about on class lecture. Okay. These are not so mandatory. Set attribute, has attribute, get attribute. These are more useful when we are learning about classes, right? So in this list dictionary, it's not more useful. It's better to use what are the functionality we already learned. Then comes slice. So we have already learned about slice. So let's create a list here. list 2 equals to 1 2 3 4 5. Okay, now if you wanted to get the three numbers of it, what we used to do, we'll create a slicing of it. So we'll print list 2, we'll put a slicing like count from 0 up to 3 not including 3, and we'll run this. So run this and we'll be getting 1 2 3. Similarly we can use the slice function. So let's put a slice function here. So how slice work, you put the start and end position. Similarly how you do for range, like put a start position 0, end position is 3. Now if you run this and just remove this number with calling SLC. Now if you run this, see, you'll be getting the same thing. But I think it's better to use the colon operator because it looks more cleaner, and this can be messed up because we need to make one extra variable. So it's better to use this. But sometime there will come a use case where you wanted to use the SLC or the slice function, then you can use that. But for now, if wherever you prefer, just use this colon operator. Okay, that is what slice is. Now comes sorted. Similarly, like reversed, if you wanted to sort an array, suppose this is one list called list 1 equals to 0 5 10 11 2 4. Now if you want to sort them, what you can do, just you can use print list of sorted and put the list 1. So now it does not convert directly into list, so that's why we are wrapping it in the list. So now if you run this, see, it will convert into ascending order 0 to 4. If you want to reverse it, just use reverse equals to, let's put in the next line, just use reverse equals true. Reverse equals true means it will just print in the descending order. Now if you run this, see, first it will print 11 10 up to 0. That is how you can use the sorted function. It's a simple function, just by the name itself it goes what it's meant to be. It's meant to be sorted. Then comes string. String is similar to how you use int, float, right? It just convert anything into string. So you can just write print str, make this number a string. It will just convert this 1 to r, which is integer, into string. So if you wanted to see this in action, what you can do is print this in x. And now if you print x and I print the type of x, then it should be clear to you. You run this, see, now it's class of string, whereas it's 1 2 3 is class of integer that we know. So that is how string works. Now come to a sum. We've used this sum when we're using list. Suppose we are creating a list called list 5. Okay, list 5 equals to 1 2 3. What is the sum of this? 6. So if you want to get directly the sum, what you can do, you can do sum and put the list inside it, list 5. Now we should be getting 6 as the answer. Now if you run this, you should be getting 6 as the answer. So let's run this. See, you get 6. That is how sum works. It's a simple function to get the sum of an sequence. Then come tuple. Tuple function is same like how list function. Just to create an empty tuple, right? Then you can use this tuple equals to tuple and it's print tup1. It will just print you an empty tuple for you. So it prints an empty tuple for you. So these are some of the functions to create an empty list, set, dictionary, tuple. So these are some of the functions that you don't have to create it using just put a curly bracket, put some number inside it to make things look simpler and easier for whoever is reading your code. Then comes to type. We already know what type is. Type is to get what is the type of it. We have already used even now itself when we wanted to know what is the type of this x. Just to know what is the type of this variable, you can use this. Suppose if x equals to 12. You know, x is type of integer, but if you want to be sure, then what you can do, you can write type of x and it should print you the class of the x. Now if you run this, this should print you the class of x. That is, the class of x is, and everything is a class object in Python. Okay, so just be careful it. Then come VARs. VARs is same like how locals and globals work, like. So this is not an important thing. You can just remove this. So then come to the zip. We have learned about zip when we are doing a list. So if you want to combine two lists, then you can do this. Suppose we are combining list 1 equals to 1 2 3. Okay, then we have one more list 2 equals to 4, 5, 6. Now if you want to loop over them in the same time, what you can do is you can do num1 num2 equals to zip, means tie both of them together. What are the list 1 and list 2. Now you can print both of them together in the form of tuple. Print num1 num2. Now if you run this, you'll be getting got the number. It's just to tie two lists together. That is how zip works. So that is the end of all the function that we want to learn. I know I went a little bit quick because there are a lot of function to learn. If you go slowly by slowly, you should understand all of them, and most of them are already covered when we are covering a topic in Python, right? We'll be using most of them. So still go through one by one of them. If you face any difficulties, please comment out and I'll be happy to share. Now let's push it to GitHub. Let's see what are the changes. Git status. Okay, there are a lot of changes. Git add all. Git commit. What we have learned today, we have learned about built-in function. So built-in functions. Now we can read git push origin main. So it's getting pushed. Now let's go to GitHub. Let's see if it got pushed. We go to built-in functions. Yes, built-in functions. Run this. Yes, we get all the function that we learned today. There are a lot of function, okay? And if you face any difficulties in any of one that idea that you thought you did not understand properly, just comment out. I'll come back to this function once again or solve in the comment section. So yeah, in the next video we'll learn about lambda, decorators and generators. That are very useful type of functions in Python. I hope you'll join me there. And yeah, that was it for today. Thanks for watching. See you in the next.